So if I had to eliminate one lecture or one lecture topic from the class, which one should it be and why? This is something new I've started this term. I'm always trying to use sort of the principles of lean manufacturing and things that I've learned to make the class better and to understand the value that I'm delivering to the students and to make sure that we're not wasting a lot of time doing things that have no value. So this year I've started, I went a few times actually. Now we've, at the beginning of class, passed out some 3x5 cards, and there was a question that I asked the students to answer on those cards. I'm trying to figure out, so I know that, I know it's important, one, for me to understand what the cards say and to see what it is, but I think it's also important to get some feedback to the class that they appreciate the fact that I've looked at the cards, that I'm trying to adjust things based on what I'm seeing. But the real idea here is for me to identify what do the students find valuable, what makes them want to come to class, and what makes them want to do better. So this was the question for week 4 of the 7-week term for the Introduction to Manufacturing Engineering class here at WPI. And the answers, I'm just going to go through these answers. I think this will be a good way to get this information back to everybody. So the first card in the pile here, we should eliminate the lectures on value. We should eliminate the lecture from 9, 12, 13. What was 9, 12, 13? So 9, 12 was we talked about NC code and we started talking about energy and power. So I have nothing to eliminate. I think it should be a whole lecture and do a better job of teaching how to do the math for feeds and speeds and RPMs and that stuff. If we had to eliminate one lecture topic, it would be the business part. I like learning, so none of them. Chip thickness and force of cut. Chip thickness and the week 3 quiz, orthogonal chips and cuts. I'm not positive. They all seem quite important. Maybe art to part. The economy stuff. Force of cut. Part failure. I don't think there was a lecture on part failure. The first lecture topic. What was the first lecture topic again? Manufacturing, science, and engineering. So in this lecture we talked about why we're in the class. None, because they're all important. One lecture topic should be eliminated as the lecture of flow in CAM and CNC. So this is where we talked about the process and the things that the manufacturing engineer has to do to take the model and turn it into a program that can run the machine tool. This person had no idea. This person says, I don't know. We should eliminate the lecture that is not interesting, one that doesn't grab the attention, one that doesn't grab the class's attention. It was sort of the whole point of this exercise was for me to learn what that was. One of the lectures about value, energy and power. Remove one on lean manufacturing. A lot of that was repetitive. Replace with one on RPM, SPM, surface speed, conversion, etc. One lecture topic I would choose to eliminate would be the one about machine power. Arrhenius equation. Lecture about NC code. Lecture about chipping. I assume this is chip formation. NC code, that's what Esprit is for. What the different G-code commands mean. Chip formation. We should note that chip formation was the lecture I was about to give when I handed these cards out. Less efficiency lectures, so I would put that along with the lean manufacturing and cost per cut. The relationship using the drill and how much the drill dulls. So I guess this is also cost per cut. I'm not sure, but I think that all the lectures before the ones with explanation of the forces should be compressed into less lecture time. So basically take the first 2 weeks and compress it into something else. The value stream map. Factory manufacturing chain optimization, so value stream map. Value and cost. It should be about lean manufacturing or value stream map. Art to part. Shear angle. We hadn't really done this lecture yet. The one where we calculated the thickness of the chip. Maybe a lecture devoted to CAM would help. Force chip formation or CAM and CNC machining, chip thickness. So I actually looked through these earlier and I came up with some totals. So the class had 10 votes for eliminating 12 votes for eliminating one of the lectures that had to do with either lean manufacturing or cost per cut or economics. There were 10 votes for eliminating the lecture topic on chip thickness, which interestingly enough was the one that we were just starting. We talked about a little bit before we did this. I had 4 votes for eliminating the lecture on NC code. So that the lecture on NC code that we did this year was actually a brand new lecture. I developed it for this class this year because I thought we were missing something in the previous terms. And I had 4 votes for the art to part lecture. So I haven't looked yet to see what lectures got no votes for eliminating. So nobody said they wanted to eliminate the lectures about CAM, and in fact, some people said they wanted more lectures on that topic. Although the CAM lecture and the NC code lecture were on the same day, sort of put together. Let's see. We've so far talked about the definition of manufacturing science and engineering, economics and cost per cut, lean manufacturing, the art to part. So this is the process the manufacturing engineer or the programmer takes when they've got the drawing and they want to make a program for the finished part. The CAM and the NC programming. We finished up some NC code and started talking about energy and power. We've got energy and power. So looks like all the topics had a vote for eliminating. I was kind of surprised that that sort of the economics, the lean manufacturing stuff got the most votes. I actually moved that to the beginning of the class this year at the recommendation of students last year who thought that maybe we didn't spend enough time talking about that and that they would understand the rest of the class better if they were thinking about this as we went through the rest of the class. It's interesting that the lectures that were just starting also got a significant number of votes. What was that? It was 10 votes for the chip thickness stuff, which is what the topic we were just getting into as I did these cards. And I'm wondering if that's related to the amount of time that I spent preparing for those lectures relative to the amount of time that I spent preparing for the other lectures. At the beginning of the term, I had a little bit more free time because there was a lot less grading left to do. So at the beginning of the term, I was spending 3 to 4 hours on the day of the lecture, before the lecture, actually getting ready for it, making sure that I knew what the slide transitions were going to be. The last couple lectures that we did, so the ones where we started talking about chip thickness, I really didn't have as much time available to prepare for those because I was spending a lot of that extra time making sure that all the grading was complete. So I'm wondering if that influenced people's decision to get rid of the chip thickness lectures. We'll see how it goes. So just so you know, I don't actually have plans to eliminate any of the topics, although I think this feedback is important because it lets me think critically about how much time we're devoting to the different topics and how I could better use that time. So thank you for your responses. I would also note that there were about 25 or 30 people not in class out of the 70. So you guys, I hope you're watching the videos. I hope you're paying attention to the assignments, but you don't get a chance to fill one of these cards out if you don't come to class. Thanks again.